Okay, so today we'll discuss the next your organometallic compound, that is your organozinc now. So this reagent is again very one can say selective reagent in the family of what organic synthesis. So now first of all, without proceeding to the organozinc, you must know about the previous reagent now. You must compare the previous reagent. Okay, and again the carbon and zinc bond is very less, one can say, the polar, and if it is the least polar it has some covalent character, you know that. Generally Mc bond is an ionic in nature. Mc, that is organometallic compounds having carbon metal bonds, are showing the which type of the nature now? They're showing the ionic nature,
Polar.
because you know that
Polar.
carbon is more electronegative than what the metal.
Yes.
But if we proceed from organometallic compounds from S block to D, then you will observe that. Okay, so look at this zinc now. So zinc ionic character is only 15. Okay, so I will just summarize the table. The what will be the basic condition here. Look at this one. This is the table, that is electronegativity values and ionic character. Okay, ionic character. Now we have variety of metals are there, and here now look at this. What elements we have now? These are the elements, their electronegativity and their percentage of ionic character. Percentage of what? Ionicity, one can call. That is percentage of ionic character. Now look at this one. Suppose I have the element is lithium, which is most polar. Then we have the magnesium as a second metal, titanium, then aluminium, then we have zinc, then we have copper, we have silicon, we have tin, we have boron, and we have last is the carbon, which is we are going to interested. Okay, now this is our interested element, that is carbon. And now carbon can make bond with all the metals, which is given in this categories now. Now what about the electronegativity of these all the elements now? So here is zero point 0.9, here is 1.2, here is 1.3, here is 1.4, here is 1.6, here copper is 1.7, here this is 1.72. Okay, copper is 1.75, silicon 1.7, silicon 1.74, Sn 1.72, here boron is 2.01 and carbon is 2.5. Now compare the carbon with all the elements now. The higher the difference, high will be the ionic character. Okay, now look the ionic character calculated from by using this difference, okay, between carbon and all metals. Here the highest ionic character for lithium is 43 now. Here this is 35, here this is 30, here this is what 22, here this is 15, this is what 12. Then what? Silicon, silicon also has the same character. Then we have 11, then we have lastly 6 now. So basically by using this table, one can simply conclude that more will be the difference between the carbon and the particular metal, more will be the ionic character now. And today we'll discuss about what the zinc. So here carbon zinc bond is least ionic compared to your previous organometallic compound, to compared to carbon lithium, carbon magnesium, and due to that less ionicity here, the ionic character for particularly the uh, organozinc is only 15 now. And if it is 15, so you can compare here. So look at the zinc. The difference is only 1 point difference between the organometallic compound, that is carbon and zinc, is what 1.9. So if the difference is less, obviously the ionic character will also what the decrease now. Okay. Okay. So that means if we consider the polar nature among the previous organometallic compound, Here carbon zinc bond is highly, one can say, the covalent in character now. So carbon zinc bond is less ionic or more
Covalent.
more covalent in nature, and hence it is a less reactive. Okay, and that's why it is a more selective type of what organometallic compound. More, okay. So that means it have limited application, selected applications. So without altering to the other functional group, it only reacts with some specific one. So that's why the utilization of organometallic compound in organic synthesis, how the main applications are what. So just we have to focus on some few applications, and these applications are example reformatsky reaction. We have cyclopropionation reaction. It cannot be used for the reduction of carbon, that is reaction of carbonyl compound. It cannot be react with the example we have at opening of epoxide, the displacement of hollow and tosylate, etc. Yeah, all these kinds of applications are neglected because this is a selective reagent, and if it is a selective, that means you have limited applications as well. Okay, so these are the what introductory part about your reagent. Now how to prepare this reagent? So preparation of organozinc now. Preparation of organozinc. So how to prepare this reagent now? So basically, there is a one reaction that is called Frank-Land reaction. Frank-Land reaction. By using that reaction, we can prepare the organozinc now. Okay. So previously, this reaction is going to proceed like this one. So from zinc chloride, that is from the zinc salt, it is reaction with the metal. Example, lithium salt. So it will converts into the pure zinc. That zinc is called as a Rike zinc. Rieke. That's called the Rike zinc. So which is prepared from your zinc chloride, and then it going to react with your alkyl halide. It going to react with the alkyl halide. So it will formation of R2Zn. So these are the some reactions. So by using that we can prepare it. So similarly, you can we can take more different alkyl groups. So example, I have butyl bromide, butyl magnesium bromide, or any other agents are there. So basically, what we have many reactions are there from which we can prepare. Okay, this organometallic compound as a organo zinc now. Okay, but in the case of what reformist reaction and the cyclopropionation reaction, so in or in reformist reaction, we are going to prepare the zinc enolate now. So there is a one reagent that is called zinc enolate, used in which reaction? Reformist reaction.
Reformers.
And the next one, that is called organo, there is cyclopropionation. So cyclopropionation means the diiodomethane and ZnCu. So zinc amalgam, sorry, zinc copper, not zinc amalgam. So ZnCu used in cyclopropionation. And beside that, the zinc is one of the widely used element in the inorganic chemistry also, for the various active sites in the enzymes now. जो enzymes होते हैं उसके active site generally वो होती है आपकी, that is called the zinc. तो जिंक कार्बेनॉइड भी एक स्पीसीज होती है. जिंक कार्बेनॉइड, कार्बेनॉइड का मतलब होता है कार्बिन. Zinc carbenoids, it is a carbon like species is there now. So let's see the example of what how to prepare that carbonite. So we have, this is iodomethane CH2I2, and here we have to activate that zinc molecule in the presence of what any zinc with the solvent is THF and etc. Okay, generally in the combination of what copper. So there is a formation of the complex that is CH2 ZnI. This that is the zinc is going to insert it in between the carbon iodine bond. Okay, and so that same compound can be prepared with the help of the CH2I2. Here ethyl zinc EtZnI in the diethyl ether or in a DCl. So we can prepare this one. Okay, and that compound that CH2 ZnI. Okay, that will be give rise to the carbene. This will give rise to the carbene, and that species is called as a zinc carbenoids. Okay, okay. So now, and you know that this carbene is going to be added on the simple double bond. That is what this is what my CH2, which is coming from that the previous the above reaction, and it going to do the cyclopropanation. So cyclopropanation of the double bond is going to take place now, and this is an example of electrophilic addition reaction. Electrophilic addition reaction. Okay. Now the first application of your reagent that is the Reformatsky reaction. We already discussed that reaction. Reformatsky.
Yes, sir. वही है ये.
So in the Reformatsky reaction, what we are to going to do now? There is a reaction between the carbonyl compound and it's the alpha haloester,
Alpha
right?
haloist.
So Reformatsky reaction is the reaction between carbonyl compound and the
Alpha haloist.
halo alpha haloester in the presence of the Rike zinc or
Zinc.
simply what pure zinc. Rike zinc means nothing but the zinc which is prepared by from zinc chloride. Okay, and it will be formed zinc enolate ion, and later on that will be reaction is going on. So there is a formation of beta ketoester. Sorry, there is a formation of beta hydroxy
Beta
Beta.
carbonyl compound is the final product. Okay, so likewise you can prepare this compound. But the complementary reaction in the organic synthesis is the Darson condensation. So Darson condensation in which
Yes, sir.
what we are using the same reactant, but
Yes, sir.
instead of that zinc now we have the
Base.
uh, we have
We
base is
use
there.
base.
So sodium
Yes.
methoxide or etc. That will be the
Yes.
base is going to be used now. Okay, so here we are interested in the mechanism part. As now first we'll take the simple reaction. We have what alpha haloester. First of all, we have to prepare the zinc enolate ion. This is my alpha haloester, and that will be a reaction with Reiki zinc or simply zinc in the presence of what diethyl ether. So there is an insertion of what that zinc is going to be takes place in the carbon halogen bond, and there is a formation of a compound that is
Ester. Zinc
zinc
ester.
bromide. This species is going to develop now, and that will undergo the resonance. And here, this is what
Zinc.
okay. This species is called as a
Yes.
zinc enolate ion. And now
Enolate.
that zinc enolate ion is going to be react with your any carbonyl compound. You can take aldehyde, ketone, whatever you have.
Hmm.
So let's take the cyclohexanone or simple carbonyl compound is going to be used now. So let's take the this is my carbonyl compound, and I'm going to react with
Inolate.
okay. Here the reaction is from nucleophile to electrophile. So let's look at the mechanism. Here this negative charge is going to be restored here, and via this carbon is going to attack onto the carbonyl
Carbon
carbon and
four.
bond onto oxygen. So here, what happened now? So this is my your O negative. This is what R. Okay.
R dash.
Here
Hmm.
I'm going to
R.
develop the new carbon-carbon bond. So this is example of CC bond forming reaction. So this is what
Yes.
the double bond, and here OH is there. Now that negative charge is joined with your
Become
reagent, that is zinc. Okay, zinc is there now,
hmm.
and along with that Br is also there. Now that negative charge from oxygen and the lone pair from carbonyl oxygen is going to make the cyclic transition state or cyclic intermediate. Now that will be the stablest one, and later on by the hydrolysis, if we hydrolyze that particular complex, okay, so what will going to take place now, that O negative will be converts to the hydroxyl group. This will be the OH. Okay,
Hmm.
this will be the OH. This will be my R dash, and here, so newly formed bond is there. This is what the newly formed CC bond, and remaining species are
As it
this
is.
is carbonide, and this is what OAD.
Beta
So here
hydroxy.
this example is called as a beta hydroxy. This is what the beta one, because here this is alpha position. Uh, this is what the alpha position, and this is what the beta. So that resulting product is beta
Hydroxy ester.
hydroxy. So I will give the simple questions again. Now we have to solve this question. So write down the question from the based on that your reaction. Suppose I have this is my cyclohexanone as my starting material, and I'm going to react with alpha haloester. So this is my alpha haloester. This is what Br. In the this is a starting material in the presence of the zinc in solvent is this one. So you will get the A. You will get what? A now. Now on the A, so I'm going to react with the heat now. So here we can also mention the heat. Okay, that means this is third reaction. And later on, I'm going to react with the reagent on the second step, that will be called as a dibel. Okay,
Double H.
okay, dibel H. At specific condition is given, that is at minus at low temperature in the presence of what TH. Okay,
Hmm.
now you will get the B from, you will get the B. Okay, and on that B, I am going to react with,
Consensus catalyst.
so you will get the C now. You will get what, the C. Now find out the A, find out the B, and find out the C.
एक कॉन्जुगेटेड ईस्टर आएगा सर, और वो कॉन्जुगेशन को ये
Okay,
रिंग
solve
अटैक
the
होगा.
problem.
Yes.
Okay.
Okay, so one by one. Then secondly, what we have another one more question. So we have this cyclohexanone molecule, and on the cyclohexanone molecule, I am going to react with the same reagent. Same. And in the presence of what zinc and solvent is benzene, etc. So you will get again A. On A, look at the difference in first reaction and in this. So on A, I am going to treatment with the acetyl chloride. I am going to treatment with the acetyl chloride uh, in the presence of a base, example pyridine. Okay, so what will be the product of that? And then later on, so that molecule that is B on treatment with the base, example sodium methoxide, ethoxide, in the presence of ethanol. So you will get the C and D other C plus D in the ratio of 99. One is 99% and other is what, the 1%. Now you have to identify which one is C and which one is D. Now the percentages are given to you now. This is another application of that particular reagent. So okay,
Yes, sir.
very simple things are there now. So we have to just arrange and we have to just look what exactly is going to be proceed here. And instead of the zinc is there, if you are using the magnesium, that reaction is called as a Barbier type of a condensation reaction. Let's look the example of Barbier condensation. So here the same reagents are given to you. So uh, example I have this is my ester, okay, alpha haloester, and I am going to react with the acetone, with the what, acetone. Instead of that zinc, I am going to use the magnesium. Again, I am get the same product. I am get the same product, beta hydroxy ester, and it on condensation. It on what, the condensation. So I'm getting what the product is. This one. Now this is what alpha haloester. This is our carbonyl compound. This is what this one, and this is
Alpha, beta, and second.
okay. These are the alternative
Yes, sir.
ways. Okay. One more we have. Suppose I have the salt of what, or this is a ester. Okay, this is a ester. I'm going to react with the lithium diisopropylamide, that is LDA, in the presence of tetrahydrofuran and the minus 78 degrees Celsius is the condition. So obviously you know that this LDA is going to abstract the hydrogen from the alpha position and
Yes.
it will develop the negative charge. This will be here O TBU and it will show the resonance. Okay, that
Yes.
means this is going to form now. Here, this is the resonance. And now that particular molecule I am going to react with your ketone now. Same ketone as I am going to use now. That is R2. This is what the ketone. But the reaction is proceed via lithium enolate, not the zinc enolate. This reaction is proceed via magnesium enolate ion because magnesium is the metal that is responsible for the same reaction is there. Instead of the zinc, we are going to use the magnesium now. And here by by the reaction with this particularly the molecule now. So I am going to get the same product now, which is also appeared in the first two reactions.
Hmm.
Okay, see here is what OTB is there, and that molecule is going to
Hmm.
remove the water. That's called the E1CB
Hmm.
mechanism.
Even
That's
CB.
called the what? E1CB, or
Even
you
CB.
can use the C H plus and water, or this reaction is called as a E1CB reaction. So you will get the same product now. So these two reactions are quite similar to that of your organozinc. Okay,
Yes.
the first reaction where magnesium is going to use, that reaction is called as a Barbier reaction. So must remember these two reaction now. The first reaction is called as a Barbier.
सर एक पूछना था।
Hmm.
ये सभी इसमें फिर डिफरेंस क्या है, क्योंकि प्रोडक्ट तो अल्टीमेट सेम ही आ रहा है ना,
Hmm.
तो
डिफरेंट
इसका
कुछ है नहीं है।
हाँ अपन मेटल डिफरेंट डिफरेंट यूज कर रहे हैं।
Yes. So here we are going to use the magnesium.
मैग्नीशियम,
And here we
इसमें
are
और बर्च
दिस इज एट
रिडक्शन
जिंक।
में ये बहुत कंफ्यूज होने वाला है। थोड़ा कंफ्यूजिंग है ये, थोड़ा मतलब हमें नोट्स बनानी पड़ेगी।
yes.
एकदम लिटिल
So
लिटिल डिफरेंस है मैडम।
तो एक एक में जिसमें आपने जिंक यूज किया वो रिफॉर्मेट्स की हो गई, जिसमें मैग्नीशियम किया वो
यस सर।
बारबर टाइप रिएक्शन हो गई। और ये वाली जो है ये भी, इसको भी हम उसमें कंसिडर कर सकते हैं। तो बीटा हाइड्रोक्सी एस्टर
बर्च
जो है,
रिडक्शन में भी सर हमने ये मेटल यूज किया था बर्च रिडक्शन में। ये भी बारबियर, वो
बर्च
नाम भी थोड़े थोड़े सेम लग रहे।
नहीं, बर्च रिडक्शन में हमने
बर्न
क्या यूज
टोटली
किया था?
डिफरेंट है।
वहाँ पे लिथियम अपन प्रेफरेंशियली यूज करते हैं, सोडियम या लिथियम,
हाँ,
सोडियम।
मेटल सोडियम, हाँ सोडियम यूज करते हैं वहां पर।
है ना? तो आप कंफ्यूजन इसमें क्या हो रहा है आपको? अब ये दोनों जो रिएक्शन है आपकी, ये दोनों बारबियर में जाती है। सो बोथ आर द सेम, बिलोंग टू द सेम कैटेगरी ऑफ बारबियर कंडीशन। सो जिंक ले लो या फिर आप लिथियम ले सकते हैं, सो विल गेट द प्रोडक्ट। Okay, so write down the one more problem. So we have to solve it now. So this is what my alpha haloester. Now suppose here methyl group is given to you now, methyl, and I am going to react with the carbonyl compound as a cyclopentane, cyclopentanone. This is also what methyl group. Now write down the reactant. The reactants are required for this, the zinc, but most commonly zinc इसलिए यूज किया जाता है कि जिंक में आपको कंडीशन जो है वो रूम टेम्परेचर पे प्रोसीड कर सकते हैं। आपने देखा होगा इन दोनों भी रिएक्शन में हमने बहुत रिएक्टिव मेटल यूज किया है, तो आपको टेम्परेचर कंडीशन बहुत मेंटेन करनी होती है, बट जिंक के साथ ऐसा नहीं होता। इसलिए जिंक को जनरली ज्यादा यूज किया जाता है। ये तो अल्टरनेटिव मेथड है। दीज आर द
ओके।
टू अल्टरनेटिव मेथड, by using that we can prepare the same product as like that of your previous reaction, but organozinc is better than what these two, because selectivity जो है वहां पे बहुत ज्यादा होती है। So write down the problem. This is what the zinc in the presence of benzene as a solvent. Okay, we have to reflex it, and the second reagent is H plus, and what? So what will be the product for this reaction? चलिए बनाइए फटाफट।
ये रिफॉर्मेट, रिफॉर्मेट।
लिख लिया आप लोगों ने इसको?
हाँ सॉल्व कर रहे
यस
थे।
गुड, सॉल्व करो, तब तक मैं एक और प्रॉब्लम यहाँ पे लिखता हूँ। हो गया?
हाँ सर।
हाँ सर
So what we have to prepare now? First of all, what we are going to prepare the zinc isolate ion.
इनोलेट,
सर
और उस पर फिर कार्बोनिल कार्बन पर अटैक किया है।
सर
डबल बॉन्ड ZnBr OET।
Okay, so and finally what?
यस
This charge is going to restore
डबल बॉन्ड
and it's going to react with the
कार्बोनिल
carbonyl
कार्बन
carbon.
के कार्बन
So it will be open. And if it is open, so you will get the CC bond.
इसी बॉन्ड यहाँ पर OH ओके।
This is what the newly
न्यू
formed
बॉन्ड,
CC bond. And later on,
डबल बॉन्ड
तो डबल बॉन्ड नहीं आएगा ना? हाँ उधर
ऐसा आ जाएगा।
OH, हाँ ये इसे, और हमने इसको O को OH कर दिया।
फिर इसको प्रोटोनेशन किया और फिर हमने इसको जो है प्रोडक्ट आपका बनाया है, इसको आपने okay, this is the product of this reaction. ठीक है,
हाँ सर,
आ रहा है क्या ऐसा?
सेम आया है सर।
यस सर अभी इसका इवन सी भी होगा ना सर अल्फा बीटा
नहीं दिया है क्या कंडीशन आपको?
हाँ दिला नहीं है ना
नहीं।
समोर काही।
अगर आप बेस वगैरह देता है या फिर हीट वगैरह देता है वहाँ पे तो देन प्रोसेस
प्रोसीड हो गया है
सोडियम इथॉक्साइड वगैरह वहाँ पे चाहिए होता है ना बेस, तभी तो होगा वो। यूएनसीबी में बेस जरूरी है। अब यहाँ पे एक मॉलिक्यूल दिया है तो जिंक उसके साथ रिएक्ट करना है आपको, तो आयोडीन है तो जनरली यहाँ पे इंसर्शन हो जाएगा और एक आपको जिंक फंक्शनलाइन मॉलिक्यूल आपको मिलेगा। जैसे ये देखो यहाँ पे this is what the ZNI and is, and now you know that the carbon zinc bond is somewhat polar है, तो और वो क्या करेगा, इस यहाँ पे वो रिएक्शन आपकी हो जाएगी, that means simple replacement of what iodine is going to takes place, and here you will get the final product like this one. So this will be my triple bond, and here अब क्या हो जाएगा, कितने कार्बन थे इसके अंदर, एक दो तीन चार, एक दो तीन चार, ठीक है। नाउ you will get this molecule, कितने निकाले टोटल मॉलिक्यूल, एक दो
एक
तीन
दो तीन
चार
चार पाँच,
पाँच
पाँच
है,
है ना?
एक दो तीन चार पाँच, एक दो तीन चार पाँच, ठीक है। नाउ आई एम गोइंग टू मेक दिस न्यू सीसी बॉन्ड हियर, कहाँ पे लगेगा बॉन्ड आपका नया सीसी बॉन्ड, इधर, ये
अपोजिट टू
रहेगा
दैट
आपका नया
ट्रिपल बॉन्ड।
सीसी बॉन्ड, ठीक है। और यहाँ पे आप जो है उसको ज्वाइन कर रहे हैं, एग्जाम्पल मैं इसको थोड़ा सा टेल्ड करके लिखता हूँ तो ऐसा आ जाएगा। So this is due to the functionalization of that particular carbon moiety. हम ऑर्गेनो जिंक लेकर उसको फंक्शनलाइज भी कर सकते हैं, लाइक ये ऐसे आपका रिएक्शन प्रोसीड होगा। और भी इसके कई सारे एप्लीकेशन है, बट मोस्ट ऑफ द एप्लीकेशंस आर फ्रॉम रिफॉर्मेंट्स की रिएक्शन। चलिए, तो नेक्स्ट इसका जो एप्लीकेशन है वो है साइक्लोप्रोपेनेशन, ये भी हमने इसके पहले देखा हुआ है। ज्यादा डिटेल में मैं इसको नहीं लेके जाऊंगा, आप वापस से वो रिएक्शन को जाके देख सकते हैं कि साइक्लोप्रोपेनेशन में होता क्या है। In the cyclopropionation reaction, what we have, you know that the very simple reaction in Simon's in 1958, Simon and Smith reported that there is a treatment of what zinc copper. 1958, Simons and Smith reported that so there is a reaction between zinc copper with iodomethane, CH2 I2 produces the species that is carbenoid. Okay, zinc carbenoid is going to be developed now. This is called as a zinc carbenoid, and that zinc carbenoid is going to react with the alkene. Okay, and there is a formation of the product is a cyclopropane. So that reaction is called as a Simon and Smith reaction. That reaction is going to called as a
Simon Smith.
Simon and Smith reaction. Now these reactions have wide application. It is a stereoselective, stereospecific, regioselective. Okay, all the selectivities are there. And now what is zinc carbonide now? A zinc carbonide is nothing but the, this is my iodomethane. This is what iodomethane, and I am going to react with the zinc copper. So here the zinc is going to insert it in between one of the carbon and iodine bond, and that will be formed the complex, that product is called as a zinc carbonide. And zinc carbonide on reaction with the olefin, this one. So what type of reaction is going to be proceed here? So here this molecule, that is your alkene, is going to react stereoselectively to what, that CH2 will make this type of a transition state here. Okay, and here this is covalently bonded iodine. This is zinc iodine. Like this complex is going to be developed. And finally, by the removal of what zinc iodide, that is ZnI2 is the byproduct. So you will get the
Remembering.
okay. This is called the Simon and Smith reaction. The examples are this reaction is stereo selective. If any one group is present, do the cyclopropanation on the sterically least crowded side. As you know that this is ZnCu and CH2I2. Now find out the reaction where zinc is going to use now. ऐसे कितनी रिएक्शन है जहाँ पे जिंक यूज होता है. अगर आप ऐसे सब जिंक वाले अलग लाते हो तो आपको समझने में आसानी हो जाएगी. But if any chelating group is there now, then we have to do the cyclopropionation on the same side. And chelating groups, for example, OH, OR,
NH2,
etc. etc.
NR.
We have to do the same side. We have to do the cyclopropionation on the
Same side.
okay. This is for the chelation part. Okay, got it.
Yes, sir.
Now we have one example from the family of what that same reaction. And you know the chemistry of carbene. Carbene is electron deficient, okay? So it always added on the more electronically rich side. Now where it's going to do the epoxidation? Sorry, it's going to do the cyclopropionation.
आइसोलेटेड
एक ही तो है ना सर, वहां पर जगह, दूसरी तो जगह ही नहीं है.
ये कॉन्जुगेशन में OH
वही ना, उसी पे जाएंगे ना.
Now where the reaction is going to proceed now. Yes.
ओके ओके.
लास्ट वाला बाहर
लास्ट पर जाएगा सर. ये कॉन्जुगेशन में है तो ये अवेलेबल नहीं रहेगा ना.
कौन है कॉन्जुगेशन में? You know what is meant by conjugation? Yes, anybody know about conjugation? On which basis we are going to call as a this is conjugated molecule?
सर सॉरी, गलत हो गया सर वो हमारा.
ऐसे कर रहे हैं आप लोग बिना सोचे समझे जो है.
हाँ ये है सर ये कॉन्जुगेशन वाला है सर. ये हमारा रॉन्ग हो गया था.
ये लास्ट आइसोलेटेड पे होगा सर नीचे.
यहाँ पे आइसोलेटेड पे हो जाएगा.
यस. और इसमें ये ज्यादा इलेक्ट्रॉन रिच ये OH को लगा है वो होगा अंदर वाला डबल बॉन्ड रिंग में जो है।
तो सवाल वही आ रहा है ना कि आपने पहले क्यों नहीं बताया फिर?
सर वो कंफ्यूज हो गया, वो हाइड्रोजन देखा ही नहीं हमने, वो बॉन्ड थोड़ा थिक था तो।
कब तक चलेगा ये कंफ्यूजन? एक कंफ्यूजन जो है वो दूसरे को इनवाइट करेगा, दूसरा तीसरे को इनवाइट करेगा, तीसरा चौथे को इनवाइट करेगा। ऐसा चलते चलते तुम्हारे पास तो एक बैंक बनी है कंफ्यूजन की। तो कंफ्यूजन जब तक दूर नहीं होगा तब तक ये चीजें आपकी में चलती रहेंगी। तो मेरा तो सवाल यही है
यस।
कि कंफ्यूजन खत्म कब होगा? आप प्रैक्टिस कर ही नहीं रहे कुछ। बहुत करनी पड़ती प्रैक्टिस इसमें, तभी तो ये रिएक्शन याद रहेंगे, नहीं
यस।
तो याद ही नहीं रहेगा कुछ। कैसे याद रहेगा इतना सारा? और ये हमने पढ़ा है इसके पहले, ऐसा नहीं कि हमने नहीं
यस
पढ़ा
सर।
है।
सर
ये
प्रैक्टिस
रिएक्शन
भी चालू है, पर क्या हो रहा है एग्जैक्टली जो आप पूछते हैं ना वही छूट जा रहा है, मतलब एक हम कर
फिर
लेते हैं तो दूसरा छूटता है, ऐसा हो रहा है।
रहा क्या होगा? उधर तो कुछ नहीं रहा है ना। पूछा वही जाता है जहाँ पे कुछ लगे ये पूछना चाहिए।
यस।
ठीक है, तो ये रहा तुम्हारा ऑर्गेनाइजिंग, ज्यादा इसका एप्लीकेशन है नहीं। So we have only this, we have few applications are there for this organozing.